Let us look at proposition number 35 of book 3 of Euclid's Elements. The proposition says, given a circle and two line segments in the circle passing through the center and intersecting each other will have equal rectangles formed by the segments of the lines. What this means is we are talking of AE by EC. This we looked at these type of propositions with rectangles we looked at in book 2. So AE by EC is equal to BE by ED. So basically the other part of the proposition says the same thing, but these segments are not passing through the center. So there are two cases. One where these line segments are passing through the center, and the other is the one where it is not passing. So let's take the first case. Now this is pretty straightforward. BE equal to ED, AE equal to EC. Not only that, they are all equal to each other. AE equal to BE, equal to EC, equal to ED, equal to AE. So since they are all equal to each other, naturally it follows that AE by EC is equal to BE by ED. Now let us look at the second case. Here these line segments are not passing through the center, right? And they are passing, or rather they are intersecting at, so this point E is cutting AC into two unequal parts. And similarly, E is cutting the line segment BD into two unequal parts. So here we have to again show that AE by EC is equal to BE by DE. We have to do a little bit of construction. So let's take the center. We know how to do that. Let's construct a line perpendicular to BD passing through F. Okay, we know how to do that. Yes. So basically we are bisecting BD, and the bisecting line will pass through the center F. Okay, so let's hide this. Now similarly, we have to do the same thing on AC. We have to draw a line perpendicular to AC passing through the center. It will pass because we already have proved point of intersection. And let's again hide this. Okay. Now let's join FE, FB and FC. Let's zoom in a little bit to make it clearer. Okay. So now we have to prove that AE by AC is equal to BE by ED. How do we go about doing that? Now notice point E is cutting the line AC into two unequal parts. Point G is cutting AC into two equal parts. And we know a proposition, right, which says that if this is the situation, then AE by ED plus GE square is equal to GC square. We know that we can add to this equality on both sides. So let's add FG square to both the sides of the equality. So what do we get? AE by EC plus GE square plus FG square is equal to GC square plus FG square. But remember, this is a right angle and this is a triangle. So here, if you notice, FE square is equal to GF square plus GE square. Similarly, FC square is equal to FG square plus GC square. So we have got these three equalities now. Now, our original equality was AE by EC plus GE square plus FG square is equal to GC square plus FG square. So now let's do the substitution with respect to FE square and FC square. Now here we have GC square plus FG square on the right hand side. So we substitute it with FC square. Similarly, on the left hand side, we had AE by EC plus GE square plus FG square. So let's substitute GE square plus FG square with FE square. So what we end up with is AE by EC plus FE square is equal to FC square. But remember, FC is equal to FB because they are radii of the same circle. So that means our equality can be written as AE by EC plus FE square is equal to FB square. Okay, so what all we have done till now is with respect to this line segment AC. Now, if we repeat the same process with respect to DB, we will end up with DE by BE plus FE square is equal to FB square. In both of these two previous statements, FB square is on the right hand side. So which means the left hand sides will also be equal, which gives us AE by EC plus FE square equal to DE by BE plus FE square. But FE square is in both the sides of the equality now. So we can subtract it from both the sides. We are left with AE by EC is equal to DE by BE. And hence we have proved the proposition. So that was proposition number 35 of book 3 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you feel somebody else can benefit from it, please do share it. That's it for now.